All right, we're going to go ahead and take a look at question number 3 from the Graphing Trig Functions Day 1 worksheet. This is question number 3. This one is a tangent, and tangent is a little bit trickier to kind of figure out what's going on, but in the long run, it actually ends up being a little bit easier because there are just less points that you have to plot. We're going to take a look at this one. So y equals tangent and then a quantity of x minus pi over 4 plus 3. So, basic idea here is we're going to try to figure out what some of those key features are that are listed here. Remember what we talked about in class, that this phase shift is going to be controlled by this. So we have a negative pi over 4, which means this thing is going to get shifted to the right pi over 4. Remember that the sign there is always the opposite of the actual direction of the shift. Anything that's with the x ends up being the opposite for lots of reasons that you talked about last year. So this is actually going to go to the right pi over 4. This one is also going to give us a vertical shift. That will be because of the positive 3 that's out here. This one is actually going to go up 3. And so we have a phase shift and a vertical shift. And what we always want to do, and even when we get into more complicated ones next week, we always want to reorient the origin of the graph. And so what that means is we're going to think about, well, where do those shifts, where do those actually take the origin to? Where does it move that specific point 0, 0 to? And so this one, I think we'll just go ahead and label these as pi. Every 4 will go pi units. So if I go pi over 4, that's going to put us here. Again, this one is actually going to go up pi over 4. Sorry, that's going to go up 3. So we'll put our other dashed line in here. And so that gives us a frame of reference. And so at this point, we want to kind of think a little bit back to the parent function for tangent that we looked at in class today. And so what we kind of see here is this thing I have circled in green here, that this is kind of the piece that we're going to work on building, and then we're just going to replicate that a couple times to get the full graph. And so kind of the key features here for this is we notice that, find a different color here that I haven't used yet, black maybe. So in this part, this is our full period here, and within that full period of pi, this origin point that's here, the origin point is exactly halfway in between there. And there's a lot of symmetry that we can actually take advantage of here to be able to graph this. Further, this point, which I said was a key point in class, is halfway of the distance from the origin point to the vertical asymptote, and that's also the same on the other side. It's halfway horizontally, it's halfway between the origin point and the vertical asymptote. And it's also just goes up 1 unit in both directions, okay? And so we kind of use that just as a framework for which we plot our points. But that part is important. We find the origin point first, we go half the period to the right, half the period to the left, and then we draw our vertical asymptotes, and then we kind of put the points in appropriately. So we'll go back to the other page here. This guy here. Okay, so we'll go back to this page and just kind of talk about that. So what we have so far is this point is our new origin, and since that is a point on the parent graph, that is going to be a point on this new transformed graph. Every single point gets slid to the right pi over 4 and gets slid up 3, so the origin would certainly be one of those. Now beyond that, this one actually has a period of pi units. There's not been any scale change thing, and we'll talk about that more tomorrow. But the idea here then is that pi has to get split evenly on either side of that origin there, and so that pi gets split evenly between to the right and to the left. So we're going to go over pi over 2. Which in this case, since we've scaled this by quarters, is just going to be here. to go pi over 2 in this direction as well. So go over 1, 2 units here. That gives me my other vertical asymptote. And then my points are going to be, so halfway to that vertical asymptote on the right, just like we did on the parent graph, we're going to go halfway to find that other point. We go halfway horizontally, and then we go up 1. And to the left, we go from that origin point, we go halfway towards the asymptote, and then down 1. It's always down 1 unless there's scale changes there, which we haven't quite talked about yet, but we'll get to that during the next class. So those are our 3 points. And then at that, once we get to that, then we just want to put this nice smooth curve in here that kind of does this. And we can recreate those vertical asymptotes every pi units here, right? 1, 2, 3, 4. We're going to have that. It's going to keep repeating over and over again, that same basic pattern. So once we get 2 of those pieces in there, then that's fine. It suffices for our 2 cycles of the tangent curve. So we can think about maybe the points of this, maybe start working on filling in some of this other stuff here. So our amplitude doesn't really make sense for tangent curves. There's really no such thing of amplitude. That's something that only really applies in sines and cosines. So we'll get rid of that. The range for this one is easy. For tangent functions, it's always all real numbers or negative infinity to positive infinity. The domain is a little bit trickier. I'm going to come down here. I don't quite have enough space there. So our domain is going to be really all x values except where those vertical asymptotes are. Remember that those are not actually points on the graph. They're places where the function itself is actually undefined. So where the function is undefined, that creates domain restrictions. And so what we want to be able to do is to define the locations of these vertical asymptotes as saying like anything we put in for x is going to be fine except for those dashed red lines that I have up there. So I guess the first one that we have there is going to be this guy here, which I guess I'll just put here. There's not actually a point there. I should have done that. But the first one I want to note here is maybe this one. Let's do it that way. That one is at 3 pi over 4. So my first restriction is going to be at 3 pi over 4. And then just notice that that repeats. Do that in green. That just repeats. So pi units more, I have another vertical asymptote. Pi units more, I have another one. And so what we can say then is that I can add on. So again, this kind of gets back to our idea of but arithmetic sequences that just repeats every pi units. It's skipping, it's jumping, it's increasing by pi every single value here. So I'm going to put plus pi k, that's the period, that's when it's going to repeat. And then I'm going to make that quick adjustment, not adjustment, but just define what k actually is. Again, we can do that one of 2 ways. We can say k is an integer, meaning that it can be positive whole numbers, negative whole numbers, or we can say that k is contained. This symbol means contained in the set of all integers, which is this z symbol that we talked about in class. So either one of those is okay. You don't have to put both of them, but other one, just noting that the only substitutions there that are allowable would be, integer values, which is kind of similar to what we did when we did sequences. We were saying, n had to be greater than or equal to 1, those kinds of things. We're just making sure that we understand what is allowed to be plugged in there. So that's pretty much it. So I hope the rest of those questions go well for you. And if not, I will post the solutions to the rest of them. And so just make sure that you check those. And if you have some questions, we can work on those in class at a later time. So thanks for listening.